Okay, good morning, everyone. Welcome to our 10 o'clock briefing today. How to grade secure, effective, cooperative AI. We have 3 speakers on our briefing. They are Jane Pinelis, Director, Test and Evaluation of Artificial Intelligence and Machine Learning at Johns Hopkins University Applied Physics Laboratory. Dan Weld, Professor of Computer Science and Engineering at University of Washington and Research Manager at the Allen Institute for Artificial Intelligence. And Don Song, Professor of Computer Science at the University of California, Berkeley, and CEO of Oasis Labs. We'll hear brief remarks from each of our speakers, and then we'll open it up for Q&A. Thank you.
Hi everyone, I'm Jane. Thank you for being here. So today I wanted to touch on test and evaluation of AI and ML, especially as it pertains to the defense community. And traditionally, we're used to thinking about test and evaluation in a couple of different ways in the Department of Defense. We usually think of it as starting with a developmental test, where we test each subcomponent of a system. We usually use models, simulations, test beds, and prototypes in that step. And then we usually move on to an operational test in which we take a production-ready system to the field and we test it under realistic operational conditions. We involve the operator and we test it against realistic threats. And so as a community of testers and evaluators, what we're asking ourselves is, how does the introduction of AI-enabled systems really change the paradigm of testing in the DoD? And we're finding that it changes things in quite a few ways. One thing that remains the same, certainly, is the need for rigorous scientific and objective assessments. We need to ensure that our warfighters can trust their weapon systems to work when they need them to. The question remains, how do we do this? And how do we do this at the speed of relevance to the warfighter? We're finding that the introduction of AI-enabled systems fundamentally changes the science and practice of test. We are used to certain processes and metrics and data, and it's all being turned on its head, including the skills that the testers need. Historically, DoD has been largely the consumer of existing scientific practices, especially statistical practices on design of experiments. And we've, for a long time, been working to introduce that kind of rigor into the DoD operational testing community. And we've done, I think, quite well over the last 20 years or so. Now what we're seeing is, with AI as being a key element of the national defense strategy, the DoD is becoming also the producer of the necessary skills and expertise and data and knowledge in the field of testing AI/ML. So the way that we are starting to think now about testing AI-enabled systems, it really comes as a process. And the process usually starts with testing an AI or machine learning model. And even within that, how do you actually test the model? There are a lot of interesting questions about the metrics that we should be collecting. There are questions about models being explainable enough so that we understand the mistakes that the models make and biases that they may introduce. And we must understand what the model's mission ultimately is and what the workflow is with AI-enabled systems. The next step in test is a test on an operationally representative system or an integrated test. So once the AI-enabled model is deployed on a fully operational system, what does effectiveness look like at that stage? And that's a very interesting question now that we're trying to deploy AI-enabled systems combined with older legacy systems in the DoD that are not necessarily meant to work with AI-enabled systems. Then we move on to what we think of as an operational test. And an operational test, there are usually several criteria that we worry about. One is effectiveness. So is the system, and this now includes AI-enabled systems, is it capable of achieving its mission, and to what extent? And one of the important questions there, again, is what is the mission of AI-enabled systems? How does it change the introduction of these systems? How does it change the missions and the workflows that we're ultimately interested in evaluating? The second question is suitability. We worry about things like reliability, mean time between failures. Do things crash? We worry about interoperability. How does it work with other systems with which it's meant to interact? And we worry about human factors here. We worry about things like trust, which I know Dan will touch on. We worry about trustworthiness. We worry about UI/UX type issues at this stage. And then finally, we also collect data and we test for survivability. So how does the system actually perform against a realistic threat? And that's become a discipline on its own, and that's actually conveniently what Don is going to touch on quite a bit, is how do we think like our adversaries, and what ways can these systems be attacked, and how well does that system defend itself? And then finally, and this is a largely new area for test and evaluation, we worry about ethics of AI, and where does that intersect with the test and evaluation that we traditionally perform in the department? That is a much more interdisciplinary endeavor that we're very excited about. We have teams of testers and teams of lawyers, et cetera, and political science experts that are working together in that field as well. So to summarize, it's a very exciting time to be a tester in the DoD. We're working very well with the academic community and with the industry, with the intelligence community to figure out how to appropriately test AI-enabled systems. And conferences like this one and panels like this one are very helpful for us to check our progress and how we're doing. Thank you.
Thanks. So I think that there's a number of interesting contexts in which AI systems are being deployed. In many cases, they're being deployed as autonomous systems. In other cases, AI systems are being deployed as part of human AI teams. So I've got a picture here of robot-assisted surgery, but there's many other examples as well. For example, we've got computer programs advising judges on the likelihood of recidivism of someone, and that oftentimes affects either sentence decisions or bail decisions. So an interesting question. In fact, also we've seen a number of business magazines predicting that many individuals are going to be working alongside human AI teams in the future. I think this is what's coming. So one question that I'm especially interested in is when we come up with human AI teams, how do we make sure that they actually do a good job? And people make lots of mistakes. Our AI systems today make mistakes. In many cases, the AIs make fewer mistakes than people, but some of the mistakes they make are truly hard to understand, and they're just kind of crazy mistakes. Ideally, we'd be able to deploy these human AI teams where we make a much smaller number of mistakes as a team. And what I've been looking at is techniques for helping AI systems generate explanations so that when they make a mistake, the human part of the team can spot that as a clear error and override it. Unfortunately, one of the challenges we're finding is that in many cases when the AI makes a mistake, it's able to come up with, for some reason, it's able to generate an explanation which is convincing, and so the human just goes along with the AI system. So one situation I'm really worried about is having these human AI teams where instead of getting the best of both worlds, we just sort of transition over and make more and more mistakes that the AI itself makes. A similar issue is not just how do we build our systems so the human knows when to trust the AI and when not to, but also to make sure that the AI systems can be updated and controlled. When the human realizes that something's wrong with the AI, how can they adjust the behavior of that AI? And fundamentally, as we think about ways that humans and AI are interacting with each other in the future, what should be the guidelines for building the AI so that it interacts in a responsible way? And working with some researchers at Microsoft, we went over 20 years worth of research into this topic and tried to distill over 150 different guidelines down into a small set of principles for guiding human AI interaction. And this work was published last spring at the CHI conference, but we boiled it down to 18 specific principles for human AI interaction. Some of them have to do with what the AI should do before interaction. Some of them have to do with guidelines for the way humans and AI should interact. Many of them have to do with the way the human and the way the AI system should deal with when it makes a mistake and ways to allow the human to override the AI, and then the most of them have to do with providing these kinds of controls and long-time interaction. There's lots of research necessary to build these systems to make them so that we come back to those teams that are our dream team, where we make a small number of mistakes working together, and that's what my research group is working on.
Okay, right. So my talk covered issues at the intersection between AI and security. I strongly believe that security will be one of the biggest challenges in deploying AI. And in particular, there are two types of issues that we need to be careful about. The first one is essentially how these AI learning systems may be fooled. And so these are called adversarial examples. Essentially, so attackers can actually add malicious perturbations, in this case actually to these stop signs, to actually fool the learning system into misclassifying it into, for example, speed limit sign instead. And our work has shown that these adversarial examples are not only effective in the digital world, they can also be effective in the physical world, and they can remain effective under different viewing distances, angles, and conditions. So there's a video. I don't know whether the video can be played, but we actually have we actually have taken a video to show that even as a car drives towards the traffic sign, the real world adversarial examples can actually fool the learning system into giving the wrong answers. And also, one difference between this versus just learning system making mistakes is that these attacks can be targeted. So in this case, for example, these adversarial examples are specifically crafted to manipulate the learning system into misclassifying into a particular target, in this case, speed limit sign 45 miles per hour. So I would say that's the first type of issues, is how these learning systems actually can be fooled and targeted to generate the wrong answers. Also, some of the recent work by my students and collaborators have shown that this type of attacks can also work in black box models where attackers don't know the details of the parameters of the model, even architectures of the model, and in particular in this case in machine translation model, that we are able to generate these targeted attacks, even fooling, for example, Google Translate. You give it an English text, normally it actually generates the right answers, but if you just change a little bit, you can actually fool the machine translation system, like the Google Translate, into giving a completely wrong answer that's actually under control by the attacker. And then that's one type of issues, is how these learning systems can be fooled. The other type of issues is privacy. So a lot of these learning systems are trained using sensitive data. It's important to ensure that users' data privacy is being protected. But in our recent work in collaboration with the researchers from Google, we showed that for a learning, for example, a language model that's trained on an email data set, which naturally contained users' social security numbers and credit card numbers, the attacker, from just querying this learned language model, are able to actually extract these original social security and credit card numbers from the original that's embedded in the original training data set. So that's an example of, as we train machine learning models, it's important that we need to protect users' privacy as well. And further extending on that, I view that today we're actually at a critical juncture in actually setting up a framework of what I call a responsible data economy. As we know that data is essentially, data is a key factor of modern economy, but a lot of this data is really sensitive, and handling the sensitive data has posed many challenges on both sides. On the user side, individual users feel that they are losing control of their data. They don't know how their data is being utilized, and they are not getting direct benefits from they are not getting sufficient direct benefits from their data. And on the other hand, from the business side, businesses are also facing many challenges. They continue to suffer from really large-scale data breaches, and also, for example, the new privacy regulations, GDPR and CCPA, is causing essentially, it's becoming more and more costly for businesses to comply to these regulations, and takes a lot of work. And also at the same time, businesses continue to suffer from data silos. It's difficult for them to actually utilize data. So, a goal of our work is actually towards building a platform for a responsible data economy. Essentially, how can we help users to maintain control of their data, and also at the same time still enable data to be utilized in a privacy-preserving way, to bring the two sides, the individuals and the business side, to both into a win-win situation where we help businesses to better utilize data in a more responsible, compliance, and privacy-preserving way, and also at the same time helping users to maintain control and also be able to get more direct benefits and be able to derive value from their data as well. I do view this as a really important question for all of us to figure out. We are seeing a lot of conversations now in media and in press. For example, recently, the 51 CEOs from top tech companies have issued a letter asking asking the Congress to actually have to establish privacy regulations and so on. So there are a lot of discussions in the space. I think it's really needed that we actually bring the different sides to the same table to figure out what is the right approach, what's the best thing to do moving forward.
Okay, thank you so much. We'll open it up to questions now. If you have a question, please raise your hand. We'll bring a mic to you, and kindly state your name and affiliation before your question. We'll start here.
Hi, Janet Ray Dupree, freelance. You mentioned hackers being able to access some of the underlying data in the learning data sets. And you specifically mentioned on the Google Translate. I'm curious whether this has actually happened in the wild, in the real world, or is this just an example of what they might ultimately be able to do? And if it did actually happen, were they interfering with Google Translate for some specific purpose?
I see. Okay. Yeah. Thanks for the question. One clarification. So I mentioned several different types of issues. Attackers can try to extract sensitive information in the training data from just querying the models. So that's a language model. Where when I mentioned the Google Translate, that's a different class of attacks in these black box adversarial examples, where in our research from my students and collaborators, the research has shown that we can generate these adversarial example, like sentences. Given English sentence, you want to translate it into German, for example, it can cause for example, Google Translate to produce the wrong answer in a targeted way.
But that was in the laboratory, it wasn't in the wild.
No, right.
Thank you.
Mm-hmm.
And you mentioned that these AI systems make explanations about mistakes that are so convincing that humans believe them, something that you were concerned about. Why are the AI explanations so convincing? Why do people believe them?
I think so. The example that we've done a number of different studies on a problem of text classification. I think it's akin to some decisions you might see in recidivism prediction or loan acceptance. But we were looking at text classification, when the AI system got it wrong, there was usually some passage in the text that supported a judgment that was different. So, for example, we looked at a number of different domains. One was just movie reviews, and the review might start off by saying, The cinematography was beautiful, but absolutely totally hated the movie. And the system would, if it made a mistake and thought that that was a positive review, it would usually find some section of text like the cinematography was beautiful. So it would highlight that passage in the text, and if the human is just looking at it kind of quickly, it would say, oh yeah, okay, so it probably makes sense, that's a positive review. That would be an example of the kinds of mistakes it might make.
And Jane, you talked about testers needing new skills now as part of this broader phenomenon. What kinds of skills will they need to do testing, and are they already being trained, or is that kind of the forefront of where things are?
I think the answer is both. So the department is very concerned with growing the right expertise, right, and then being able to hire and retain the right expertise of testers and in general expertise that has to do with AI-enabled systems. The skill sets that are needed are actually really growing in diversity, which is very interesting to see. So in addition to traditional kind of statistical type expertise, which, by the way, is still very hard to come by in the department, we also are very heavily focused on cognitive psychology type disciplines now, right? Because we're working with things like human factors. We're trying to figure out how do people learn and how do people think in order to try to figure out how machines are best and how do we need to design them or test them to learn and think and explain how they're thinking. So there's a big emphasis on that, and that is fairly new. And then adversarial AI as well, the ability to think like our adversaries, the ability to hack and things like that are becoming incredibly important too. And then finally, as we move into these ethical considerations, knowledge of law, knowledge of political science, and those kinds of disciplines are becoming really important as well. And all of those are fairly unusual in the testing realm. We're used to kind of needing more statistical or physics-based expertise, and we're moving into this much more diverse way of thinking with AI-enabled systems.
Question here, and then we'll come here.
Tom Keenan, Business Edge. I spoke with the Commodore in the Canadian Navy, and he made a couple of interesting points. He said one of them is we need a lot more people now in the weapons control room. He said it didn't cut putting in new technology didn't cut our head count. He also said they have a principle that it takes a human being to actually pull the trigger to kill somebody. Does the U.S. military have that same philosophy?
So I want to be careful about commenting on the behalf of the U.S. military here, but I will say that ethical concerns are very largely considered in the DoD, and probably much more so than by our adversaries, I would estimate.
You made that point about the time, right? Mm-hmm. And the Commodore said that too. And we have to sometimes hold so the human can get in.
Absolutely. So I would say that the way we're looking at AI-enabled systems now are not to replace a human by any stretch of the imagination. What we're looking to do more so is to perhaps automate some of the mundane tasks so that the human can focus on more cognitively engaging and more cognitively difficult tasks. I'll also add here that just because we're talking about the Department of Defense, the AI systems that we care about are not necessarily all weapon systems. There are systems for automation of business processes, for instance, as well. And importantly, there's warfighter health issues that we're very focused on. So as you probably know, computer vision systems can be used in cancer recognition, for instance, right? Or we worry about things like suicide rates in the U.S. military, something that traditional analysis has struggled with for a long time with predicting who's most at risk, and we're hoping to employ AI in those categories as well.
Question here.
Robin Williams, ABC, Australia. Some of us feel swamped by machines with information, so much so that I have no mobile phone and have no intention of getting one. Why do you say these are the best of times for your field?
So I've spent my career as an operational tester in the Department of Defense, and most of it has revolved around bringing techniques that already exist in statistics, bringing things like design of experiments or small sample size techniques or other inference techniques, really, or operations research into the Department of Defense and sort of figuring out how to help them test responsibly, how to test them, how to help them test under financial constraints or time constraints. The reason I'm especially excited to be a tester now is because the department is not just the consumer of existing science. The department is actually a producer of new science, because it's creating that demand signal for that diversity of thought. It's creating the demand signal for new techniques and methods and practices. And so we're finally at the forefront of something. We're working with academia, we're working with the industry, rather than consuming knowledge that has existed in other sciences for quite some time.
Jane, would you be able to give us some kind of high-level commentary on how, outside the U.S., other militaries are thinking about AI-enabled systems, what that looks like, or any particulars?
I'm by no means an expert in that field, so I probably should not.
Okay, thanks. But you mentioned that for the AI-enabled systems, the mission, there's different questions, different views on what the mission should be. What are those different views? What might the missions be? How would that vary?
Sure. Well, we're moving into an age where we just process, or we have access to a lot more information, right? And so the question becomes, how do we process that information effectively and efficiently? And we're finding that humans are not able to process that information at the speed at which it arrives. And so where you have currently, these very intensive manual processes that our warfighters are having to deal with, the question is which parts of that are we okay automating so that they can spend their time differently? And that's one of the interesting things in test right now as well, is when we focus on developing these systems, we're largely focused on which part of the human workload can we maybe automate or delegate to a machine. But interestingly, once that happens, the entire workflow will change and their entire mission might change. And so we have to be able to test to that as well. And it's changing our test paradigm because we're used to testing a system, and once it accomplishes some level of performance, deploying it into the field. What we're finding with AI-enabled systems is that testing never stops. You continue testing once the system is in the field. You continue interacting with the operator the entire time.
The systems that you will try to create, Don, that help the user data be protected, that also help the company get the maximum amount of information. What are the biggest hurdles to creating such a system, and why is that taking so long? I guess we've all been kind of hoping that would be out there. Yeah.
Thanks. That's a really good question. I think the problem domain is extremely complex because there's a natural tension between utility and privacy. So on one hand, you want to get information out of data so that it can help you to make better decisions and so on. But on the other hand, this directly conflicts with the notion of privacy. The goal is to protect information in the data to be extracted. So essentially, we need to enable this balance between still being able to get utility out of data, but at the same time, you protect individuals' privacy. So the problem itself is very complex from a technological perspective, and also from business model and from incentives, it's also very challenging. So for example, so I briefly mentioned in my talk that one domain we are working in is this privacy-preserving genomics. So for example, so there are these direct-to-consumer genomic companies where users can get your genome sequence, and then you can get information about your ancestry, or you can get information about what kind of tendency you may have in terms of disease and so on. But then there's a question, actually, who is the owner of this genomic data? So certain genomic companies, they actually utilize the data. They may sell the data. They may allow farmers to access the data and so on. And there has been, for example, for 23andMe, there has been criminal cases solved using that data. So then the question is, right, in this case, actually, who should be the owner of the data? So one challenge we have seen is one thing that we have been working on is to actually enable users to become owners of their data, and they can specify how their data should be used. for example, the genomic company may be able to run genomic analysis on the data, but that's the only thing they can do. And they can, with our technology, they will never be able to see the raw data. They can only run the analysis on the data in a secure execution environment. So then in this case, users can enjoy the benefits of this genomic analysis, but they can still maintain control of their data. For example, the genomic company can now go take the data and go sell it and so on. So then in this case, it seems that to the user, actually it's really beneficial to the user. But on the other hand, then the question is, now with this genomic company, the business model changes because they cannot take the data and sell the data and derive revenue from there. Then potentially, how do they get their revenue? So now they are charging users as a subscription service, for example. Essentially, now users have to pay. And so then there's a question that we are studying now is whether users want to pay essentially for better privacy, for better control of their data, and how much are they willing to pay. So I think this is a fundamental challenge. Also, as in general, users have been trained to enjoy, in particular, these free services on the internet and so on. And at the same time, users' data is being monetized. So on one hand, users can complain that, the company is deriving value from users' data without users getting essentially a cut back from that. But on the other hand, users they also really enjoy their free services. Many of them probably don't want to pay for that service. So that's another challenge that we are seeing is this incentive, what's the right business model, whether users are actually willing to pay, or if users don't pay, then what is the business model that actually can enable this type of privacy-preserving or privacy-first applications. And then the third challenge I would say is really in the regulatory side. A lot of notions are not even clear. So, for example, ownership of data, like whether we can actually establish this type of ownership of data, like who owns the data, like whether we can establish framework for data property rights and so on, and who gets to decide and how we can decide like how data should be utilized. I think there's a lot of open questions there as well.
Thank you. Question over here.
So I'm keen in Business Edge. I wrote a book in which I encourage people to be very stingy with their data and sometimes to give false data. So when I went to 23andMe, I provided my dog's name. I even got a prepaid credit card and registered it in my dog's name to a laundromat in Denver. I'm wondering how much of a factor people doing this little bit of white lying is. And also, if you can comment on the unintended consequences. One of them is I now have in real life relatives going, I seem to be related to this person, but it's like a dog's name. Is that really you? So are people faking data, and is that a significant factor? I guess a question for anybody.
Yeah, that's a very good question. I think actually there has been studies showing I think one can set up a fake profile on LinkedIn or Facebook, and you can get lots and lots of friends. And on LinkedIn, I think they even get job interviews for that fake fake person and so on. I think that's another challenge in this data economy going forward is that like fake data can be generated, and it is being done so. And I anticipate that we'll see more and more, especially when there is incentives and so on. So it's another really important area for us to work in. Yeah, I'd love to learn more about your book.
I think that there's a couple interesting things that come out of the fake data. So on the one hand, if there's only a small amount of fake data, then I think the machine learning algorithms can handle that very, very well. The question is what happens when there's more fake data? And there's been questions where people trying to estimate exactly what percentage of the internet is actually generated by people as opposed to by bots. I'm not sure what the latest numbers are, but I think that there's a huge challenge, especially with today's AI, generative models that can generate, for example, completely realistic-looking pictures of people who never existed, and can generate videos of President Obama saying things that he never said. With that kind of AI-generated fake data on the internet, I think there's going to be some very, very real challenges for how we manage information and democracy itself.
Safeway had a discount card that tracked right down to what you bought at what till. And there was a guy who published his online. And so lots of people, there were 200 of them shopping at any given time. And I called the data people and I said, doesn't this bother you? They said, that's like a pebble on the ocean in the sea of data that we have.
Pebbles are getting bigger.
Right. And also, yeah, that made some really good points. And one more thing is that with this fake data, so another type of problems for these learning systems is data poisoning. Because they are trained on training data, when you have this fake data or even poisoned data points, they can really cause the learning system to learn the wrong model. So some of our recent work showing that actually to fool the learning system to learn the wrong model, you don't need a lot of poison data. Actually, even very, very small number of poison data points, they can actually really cause severe problems for these learned models. And in particular, we designed a new type of attack that we call backdoor attacks. So these are essentially caused by just introducing a very, very small number of fraction of poison data points. And they can cause a learning system to misbehave, but only under some under certain circumstances. So for and the learning system will behave normally under most of essentially the rest of the scenario. So for example, we show that. With the facial recognition system, we can train by just injecting a very small number of poisoned data points. We can train the learning system to recognize, for example, if the learning system wants to recognize whether someone is Dan, we can train the learning system to recognize anyone who actually wears a type of glasses to be Dan, and this will only be triggered by that type of glasses. So normally for people who don't wear that type of glasses, the learning system will behave just fine. And they would recognize Dan correctly, and they will recognize Jane as not Dan, and so on. But in this case, an attacker who wants to impersonate Dan, they can just have Jane wear these glasses, and then suddenly the facial recognition system will recognize Jane as Dan. And for this attack to be effective, actually, we only needed to inject a very small number of data points. And actually, from the photos, if even humans to inspect the photos, they can't even see these type of glasses in the photos.
One other thing that I'd like to throw in this discussion is that not all synthetic data is bad data. Right. In some cases, we can use synthetic data to train our models in situations where we couldn't obtain real data. We can use synthetic data to test under those conditions as well, and to find model vulnerabilities where otherwise it would be very hard to do.
Question from an online viewer?
This question is for Jane, and it is from Nicolas Luco from El Mercurio in Santiago, Chile. He asks, a survey company in my country which provides qualitative results after phoning and processing hundreds of thousands of phone answers to a general open question claims that there will be capacity to point out emotions in these recorded voice answers to increase the quality of their reports. Is that possible?
I think so. The field of speech analysis is actually quite large in a variety of languages, and you can start getting at a lot of interesting issues with speech analysis, emotions included in that. You can also derive that from written speech. Absolutely.
Okay. If there aren't any other questions, thank you so much to our speakers. That was a fascinating briefing, and we really appreciate your time. Thank you. Thank you.